Welcome back to MPB's boot camp for the math portion of the ACT. I am Ms. Killen here to make sure you get the best ACT math portion score that you can. So let's go ahead and dive into lesson 16. We are looking at a different strategy, which is picking numbers. Now, we're just not picking numbers out random and throwing them in there and saying, whoo, here's the answer. No, there is a strategic plan in when we pick numbers. So let's go ahead and dive into this. And it says, picking numbers is one of the most easiest understood techniques after traditional math. Now, we've gone over how to use traditional math, but let's say I've just not learned that traditional math for this concept yet. That's okay. We have this option. The goal of picking numbers is to take an abstract algebra, geometry, or a logic item and make it concrete by using numbers that we pick to obey the rules that we're given. You can generally pick numbers under the following circumstances. Answers contain variables. Items is about number operation, odd, even, prime, composite, stuff like that. Positive, negative. Items often ask you about statements and conditions that are true or that are false. Items ask about relative ratios of numbers, especially percentages without specific number variable or numeral values. So you want to make sure that you're looking to see what the question contains and what I'm going to have to do with it. And sometimes, hey, I can just pick a number and help me work through that to get the correct answer. So let's look at some of these. It says how to pick numbers. Like using traditional math, picking numbers is another useful strategy applicable to many of the test items that you'll have. Look for numbers like non-zeros, integers, prime, positive. Then pick numbers that are easy to work with. Normally 3 is easy to work with. It's a whole lot easier to work with than 7 or maybe 13. And you especially want to make sure that they're going to be easy when you have to multiply or divide. Because I'm sorry, dividing with 13, that's going to get a little difficult for me. So I'm going to use those numbers that are easy. It's also, we want to make sure that if an item or an answer choice refers to a positive or negative value, that we pick both positive and negative so we can see if we have to reverse them depending on the variable or we reverse them depending on which one is larger or smaller. So we always want to make sure that we're looking at that as well. All right, so let's look at some examples to see how we would use that picking of numbers. So it says, which of the following expressions is a factor of x to the third minus 64. Well, some of us see that as a difference of cubes. Now, you may have not learned difference of cubes yet. So let's go ahead and pick some numbers. So I'm going to tell you how to work this, but I've also written down on our slide how to work this because some of us, it may be difficult for me to walk you through it verbally, but if I can read what Ms. Killen is saying, then I can put a little bit more connection with it. So let's go ahead and start. I'm just looking at x to the third minus 64. I'm going to use some numbers. I'm going to say that x equals 3. All right, we're going to say that x equals 3. Now, if I chose a 1 or a 2, I may not get what I need because of this difference of cubes. So I want to avoid some numbers in some of the cases that we use because it's not going to complete the operations that we're doing. All right, so we want to make sure that we put x equals 3 by the problem that we're working so we know it's just another way to remind us, okay, x is going to equal 3 in this problem. So the first thing that we want to do is 3 squared minus 64. So I've got 3 squared minus 64 is the same thing. If you do 3 squared, that's 27 minus 64. And when you plug that into your calculator, you get a negative 37. So, however we're looking at this, when we look at these different answer choices, I want to make sure that I'm looking at factors of that negative 37. All right, so let's go ahead. We're using x as our number 3. So I have 3 minus 4 equals a negative 1. Well, is a negative 1 a factor of negative 37? Absolutely. So this is a possible answer choice. But let's go and see if we can find a better answer choice. So let's look at the next one. So I have 3 plus 4. And 3 plus 4 is 7. Is 7 a factor of negative 37? It's not. So I'm going to eliminate answer choice B. I'm going to eliminate it because it can't be. All right, so my next one is 3 squared plus 16. So 27 plus 16. So when I put that 27 plus 16, I get what? All right, so I am going to get, oh, I made a clerical error. Let's go back to those common errors, and we are using our exponent wrong. Instead of having the 3 cubed, now I'm looking at 3 squared. So that can be something else that we're going to have to make sure that we are looking at. I'm no longer looking at 3 cubed, I'm looking at 3 squared, which is 9. So that's something that we also need to make sure. I want you to remember, any clerical error can change what you get. So 9 plus 16 is 25. Is 25 a factor of negative 37? So I'm going to eliminate that answer choice. So let's look at the next one. So I have 3 squared minus 4 times 3 plus 16. So I have 9 minus 12 plus 16. So when I have 9 minus 12 plus 16, I get 13. Well, is 13 a factor of negative 37? It's not. So I eliminate that one, so my only possible answer choice could be A. So I have picked a number, put it into all of my answer choices to see if it was a factor of what I got from the original problem. So this is one way that we are using those picking numbers. I want us to make sure that we are using all possibles that we can. So let's go to our next one. I erase this board. So we have a formula to estimate the monthly payment of P dollars on a short-term loan is P equals 1/2 A times R times Y plus A divided by 12Y, where A is the dollars in the amount of the loan, R is the annual interest rate, which we've learned about that, expressed as a decimal. You need to remember it's expressed by decimal, is our interest rate, and Y is the years, or the loan, the length of the loan in years. All right, so it says when A is multiplied by 2, that's key, what is the effect on P, which is our principal? All right, or it's not our principal, but our payment. So P is our payment. All right, so I am looking for how I'm going to show that P is being manipulated by multiplying 2 to this whole type of formula. So the first thing I'm going to do is look at this complex problem and just pick a number. We want to make sure that we are picking in numbers that make sense for this problem. I'm not wanting to use like 27 or 1 year loan. No, let's go ahead and use 2. Let's just use 2. We're multiplying by 2, so we've already got that number in the problem. So let's just go ahead and use 2. So, excuse me, we're going to say that A is the amount of our loan, and we're going to use $100 for it. R, which was our interest rate, we're going to say that's just 5%. These are easy numbers to use. All right, and I'm going to change that to 5%. It's small, it's easy to use, and it's not going to be very cumbersome when we start doing multiple types of operations. So then what we're going to do is we're going to look and see what our Y is. Now, we're going to say that Y is 2 years. That's where our 2 comes in. We're just going to use this whole long length is 2 years. So let's go ahead and plug that in. So our payment, which is P, and we're going to put 1/2 times 100 times that 0.05, and then we're going to multiply that by 2 plus that 100 over 12 times 2. Now, that's a calculator skill. I can put this whole thing in a calculator, and it's going to give me a decimal. So P is going to be 4.375. Now, I want to make sure that I put P sub 0 equals A to equal 200, because I'm multiplying everything by 200, or excuse me, by 2, remember. That's what we said we're going to use, was the 2. And then it also said in our problem over here that we were multiplying it by 2 to see how P is going to be manipulated or multiplied by that 2. So when we put the 2 in there for our 100, we go back and plug this in, and we are going to get for our payment now 8.75. So we have 2 p sub 0. So when I am multiplying by 2, I can say that my payment is also being multiplied by 2. So therefore, I have picked a number. I've gone through, used some math to make sure that when I picked that number, that it was going to give me absolutely what I've got, because when I multiply this by 2, I get my next number. So that is how I'm using these different types of strategies, because you may not have known how to use the interest rate, or you may not understand about having to have a principal and have to have payment and how to do the different things when you come across these interest rate problems. So just picking a number and plugging in what you know for the variables and then just plugging that into your calculator, 9 times out of 10 will help you find that correct answer. All right, so let's look. The next example is more difficult item when it shows the technique works for negative numbers. Now, we always got to remember about those negative numbers. Okay, this adds another key facet, must be true, which means that it can't not be false. It can never, never be false. Not, never, never, never. Cannot be false ever. So, if we set numbers which make these choices false, then we have to eliminate those answers. So, let's go ahead and look. If A is less than B, then the absolute value of A minus B, it says, which of the following are true? So I am going to use some odd numbers. I'm going to use one odd number, I'm going to use an even number, just so we can see what we've got. So let's use 2 and 5. 2 is less than 5. So let's go ahead and plug this in. So the absolute value of 2 minus 5 is a negative 3. Absolute value of negative 3 is 3. So when I plug these into my answer choices over here, I want to make sure at the end I get a positive 3. So let's go ahead and look at that. So I have 2 plus 5 equals 7. Well, I'm going to eliminate that because that's not what I'm looking for. So then I have a negative 2 plus, is it 2 plus 5? Yes, 2 plus 5. So I get negative 7. Again, I am going to have to eliminate because that's not what I'm looking for. All right, so I'm running out of room, so I'm going to erase this one so I'll have some more room to write. Then I have 2 minus 5, which equals a negative 3. Okay, I'm not really looking for a negative 3. I'm looking for the absolute value of a negative 3, which is what? 3. So let's just go ahead and double check this. So then I have 2 minus 5. So I have negative 3, and then comes that distribution of the negative. Negative times negative is a positive, so my only possible answer choice is going to be J. You want to make sure that when you choose these numbers, it goes along with the rule, and it makes it easy enough that the answer is small enough that you can use and manipulate the different operations. So, good job. All right, which of the following conditions will the sum of the integers m and n always be an odd integer? Now, we know what odd is. 1, 3, 5, 7, 9, and so forth and so on. So we know what an odd integer is. So let's go ahead and look at the answer choices before we start maybe picking some numbers. So it says m is an odd integer, n is an odd integer, m and n are both odd integers. M is an odd integer and n is an even integer. So it wants to know which of the following conditions will the sum of m and n always be odd. So we're going to get odd numbers. So let's use 3 and 5. I'm using easy small numbers. Okay. So if I use 3 and 5, all right, obviously this gets me an 8, correct? All right, so my total is even, so I have to eliminate when one of them is only odd. So I know that F cannot be the answer, G cannot be the answer. H says both of them are odd. All right, so what if both of them were odd? 3 plus 7 equals 10. They're both odd, so that can't work. So I know that H cannot be my answer. But what about if one was odd and one was even? 3 plus 4 is 7. Okay, maybe that's a fluke. Let's look. 3 plus 6 is odd. One more time. 3 plus, I don't know. Let's see. 15. Nope, that's odd. 14. Okay, so I've done 3 different cases. I've thought about numbers that I could possibly pick. So obviously my answer has to be where one of them are even and one of them are odd. So I'm going to pick J as my answer. If I did not remember those those rules that we've learned, I can just use answers or numbers. I can pick numbers to use. 3 was even, 4 was odd, 5 was odd, 6 was even, 9 was odd. So you want to pick numbers that are easy for you to do operations with that can still give you the conditions that you are looking for. Now guys, I know some of these strategies are maybe a little different than we've learned, so I want us to make sure that we are practicing these strategies so when we get to these problems that are a little bit more difficult than we're used to, we know what to do or how to use them. So as always, practice, 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 and I will be back later with more strategies to learn. Have a great day.